Cool. Then we'll continue with the next presentation. This one, we're going to talk about some extension functions that are on the collections, on the Java collections, which are declared in the Kotlin standard library. And we'll just basically go alphabetically to all of them. If some have a partner extension function that is called differently, I'll also cover that. So we'll start with the all. The all is basically, it's declared on anything that you can iterate over. And what it will do is the function that you pass inside has to evaluate to a Boolean. It will call your function with every element in the iterable, and you return a Boolean. And the first time you return a false from it, it will break and it will return false. If everything inside the Boolean evaluated to true, it will return true as well. So you're basically making sure that every single item in your collection basically conforms to some expression that you want it to check. The none function is the exact opposite. Every single evaluation of the block has to go to false. The first time you return true, it will return false from the evaluation block. It basically says that there is an item inside which does not evaluate to false. The next one are kind of a few of them. They're called any, find, and single. They all search for one item within the collection. And in the case of any and find, the first item that returns true will stop the going through the collection. It means that you found the item. In case of any, you weren't really interested in the item itself. You were just interested if there is an item like this. In case of find, you're actually interested in the item, and it will return the item itself from the collection. From the collection. In case of single, it will always traverse the entire collection that you're iterating over, and it will throw an exception if more than one item or less than one item, basically 0 items, evaluated to true. So it will return true on, it will return actually the object itself, but only if that is the only object for which the evaluation function returned true. The next one are conversion functions. Basically, you can convert everything to another collection. There are already predefined functions for converting to lists, to sets, to mutable lists, to hash sets, to pretty much any other collection that is part of the standard Java collections API. And then there's one additional one which says toCollection, which you can convert to a custom collection. So for example, if you want to use a fancy Guava collection, then you can just say toCollection, instantiate the Guava collection that you're interested in, and then you can convert any other standard collection to like a Guava collection. Or you can convert in between any fancy collection. So I don't know, you can convert a Guava collection to some other fancy library out there. So this allows you to relatively easily convert one type to another. The only difference is the as keyword. So in case of the to, it will actually create a new instance that has the items that the previous one also had with just a different type. In case of the as functions, there's basically just as list and as set. They're only and as sequence, but I'll talk about that a bit later. As list and as set will just wrap the current collection into a list and a set, and then basically they'll behave as if they were a list and a set, but it's not going to do any. They're very fast, so even if you have like a list of thousands of or millions of items inside, and you wrap it into another one, it's not going to copy every single thing in the new one. It will just wrap around it, and it will be relatively fast. Iteration might be a bit slower because of it, though. So just something to be mindful of. The next one is associate. They're a family of functions, and they're used basically to convert a list into a map. So you want to create a map by creating keys for every single item that is inside your list. There's a few ways to do that. You can basically just transform every single item into a pair, and it will create a mapping between these two items that you return. You can associate only by creating keys and not altering the values, or you can create associate by two, which will basically pass each value where you can convert the value to a key and then the value to a different type of value potentially. So you can do these to kind of transform a list into a map. There are also 5 component functions. They're called component 1, 2, 3, 4, 5, and they're used for destructing. Destructing is a operation in Kotlin where you can either assign a destructible item to or destructible object to multiple other objects. So in the first case, I'm creating an array of 4 integers. And in the second assignment, I'm just giving that array on the right-hand side of the assignment. But on the left-hand side, I have 4 separate values that I'm declaring. I'm actually interested in only the red and blue of the array. So this is a representation of a pixel. Each of these 4 integers in the array are actually my alpha, red, green, and blue. And if I want to read only the red and blue, I can just destruct the array into its components and then easily use these 2. You can use that. It's very useful within when you pass single items into a function. So for example, in the let function, I can just say, hey, I'm interested actually in just the alpha and red. And I'm comparing if those are the alpha and red channels of our Yelp red. And if they are, then I evaluate all of that to Boolean, and I just say, hey, this color actually has potential to become a Yelp color. You can do that also when you're iterating through items and so on. So you can use destructing in your argument. So instead of the way you use that in the argument declaration section is for each where you would usually have a single argument, you would use brackets and then list the number of additional arguments that you want to do. In this case, yeah, it's destructing the array into just the first 2. It's important to have like there are 5, but you don't have to use all 5 of them. So this is an array. You can have 500 items inside, and you can access through this only the first 5. You can't say you can't destruct into more than 5. And that's a bit of a convention in Kotlin. If you have something which uses more than 5 parameters, you probably should be passing it as an array or some other data object. And you shouldn't be just passing single items around that kind of have semantic meaning in a group of them. So that's why there are just 5 of them, and they haven't done them all the way to, I don't know, 10 or whatever. So destructing works for anything that is up to 5 items. It also works for all data classes. Data classes automatically get these as well. So the first 5 arguments in your data class are quite important because you can destruct your data class into these 5 arguments with a single line. Also, if you just iterate over items that are data classes, you can easily also destruct into the components that are inside. The next function is called contains. It's mapped to the in keyword. In is actually not an infix function; it's a keyword. And the reason for that is because it actually inverts the arguments. It's a bit unfortunate, but the way it works is in there, if you see the left-hand side and the right-hand side of each of these 3 are the same. So if you say 5 in day is the exact same as saying day contains 5. The reason why in is a bit more preferable over contains is that it also the negation is a single argument is a single operator. In the normal function invocation, you'll have the negation before the contains function. So if this wasn't just a single variable, but like let's say a variable and 3 method invocations and then a contains, the negation becomes very far apart from what exactly gets negated. And with this argument, it's much more clear where exactly you're checking against. So it's a convention to prefer in over contains if you can use that. Then there's filter functions. There's a whole lot of them because they're a bit different for maps than they are for other iterables. Because you can filter on keys, you can filter on values, you can filter on the entire thing. But basically, all of them return the same type that they're getting. So if you filter a list, you'll get a list. If you filter something else, you're going to get the same thing back. And what it does is it will evaluate the expression that you have inside. And for everything where, so in this case, I'm evaluating if this is in the range 9 to 17. For everything that this returns true, it will be put into the final list that I get. For everything where it evaluates false, it will just not be there. So basically, yeah, filtering. If you return true, you get it. If you return false, you don't. Sometimes it's a bit, as I said, sometimes you use the function instead of this because it's nice. You can easily get a reference to it. So instead of saying it in this variable, because this lambda gets evaluated 24 times, this is the way to create a sequence. So basically, the sequence gets created 24 times. In this example, this sequence gets created only once, and the reference to its contains function is being passed as the filter for this other sequence. And in this case, it's a bit more efficient, a bit more memory efficient. So sometimes you would still use the contains function, but they're basically equivalent. The same will happen. The upper one will just use a bit more memory. The other one is distinct. It's kind of like toSet, but it returns you a list and also maintains the order of items because the default set actually doesn't. It's probably the exact same as toOrdered set. It's just a different thing. So you get a list out of it instead of a set. So yeah, but that's the functionality. Basically, it will drop items which evaluate to the same. So if you compare items, it will and the equals method evaluates to true, then they'll be dropped, and only one of them will stay inside. Yeah?
Can you pass a comparator to distinct? Like, how do you want to compare your objects?
Yes. So I don't have an example here, but it's a family of functions. So some of them are so if you can invoke this either on a list which actually has items which are comparable. So they implement a comparable interface, or if the items themselves don't implement a comparable interface, you have to pass in a comparator. But you can also pass in a comparator even if they are comparable. Then it will use your comparator instead of the natural order. So yeah, you can do that with a custom one. The drop and take. When you go through a list, you can say drop the first or drop the last. Items. Just drop is basically drops from the beginning of the list. Drop last is called if you want to drop from the end of the list. And take is the opposite. You just say take from the beginning of the list this many items, and take last is from the end of the list. Take this many items. It will maintain the order in which it is taking and dropping items. And also you can say drop while or drop while at the end or something like this. You can look it up. It's in the documentation. But basically, the functionality is it will you pass in a lambda, and as long as that lambda evaluates to true, it will continue dropping in the first case, or continue taking in the second case. And as soon as this evaluates to false, it will just stop and return only the items that it either took or left in the original collection. Then there's Flatten and FlatMap. Flatten is declared on basically any collection that contains a collection of items. And what it will do is it will just return you a list of all the items which are in there. So it's basically, and yeah, this works on any number of nested. So if you have like 3 collections nested inside, you just have to call flatten twice and you're going to get it out. The FlatMap is you just create a transformer where if you have a complex object and you want to create a list out of some of its components. So for example, if you have, say, a list of businesses and you want to have a list of addresses for like auto-completion suggestions or whatever, and each business can have 0 to 10 addresses listed, then you basically use FlatMap and you return the list of addresses for each of the businesses, and it will do the aggregation for you and give you just a single list of all of the addresses from all of your businesses. Fold and reduce, for folks that are familiar with MapReduce, this is basically the way you turn a collection into a single item. You start with some initial value, you perform some operation in which you get every item and you do something with it to actually fold it into the accumulator. The difference is that in reduce, the output is of the same type as the elements that are inside. So for example, an example of a reduce function would be average or mean, max, your percentiles and things like this. So you're going over some numbers and you're producing a number. In the fold, this is not enforced anymore, so you can fold businesses into a string or any other things, or addresses into lat longs or anything like this. So you can basically produce a single thing from a list of things. Oops. The for each and on each, they basically do the same. For each item, it will go over the collection and execute the lambda that you pass it. The difference is for each is a ternary operator, and it will not return anything after you're done iterating over your items. On each will return the same collection on which it's operating, so you can chain multiple additional operators on it if you want to. The join to and join to string, basically a nicer way to fold things into a string. They already declare some things that by default nice to have. So you can add a prefix, a suffix, choose your separator, limit to a certain amount that you just want to fold from your array, declare what your truncated string is going to be, and basically you still have to declare the lambda, the last operator is there, which will do the transformation. The default is null, which means basically it will use the toString method to actually append the items to your string. ToString, basically the buffer is basically a string. It returns also the string, and that's the difference. If you want to append to something which is appendable, so in Java appendable, basically can append anything that is a char sequence. So for example, you can join a list of things into a spannable builder, for example, which is where you can, I don't know, you can add some additional markdown to, I don't know, put things in different colors or bold certain sections or what have you, because these are not really strings. So each of these you have to create a span string and then put it into a spannable, and then you'll be able to create from a large list of things a nice string that is well formatted. Then there's the min, max, and average operations. Not much to talk about. For each of the items, you have to return an integer, and it will do the math and give you what's the biggest, the smallest, and the average. Plus and minus, you add two collections, you get both collection that is as long as both of them are. Minus will remove every single item that is in there. So it will remove from the first collection everything that is in the second collection. And then there's OrEmpty, which is really nice. It's actually declared, the OrEmpty is declared on the nullable collections. It's actually declared on almost all collections here. I'm showing it for a list. But what it allows you to do is just not care about, like convert your potentially nullable lists into empty lists, and then you can chain other operations on that. So for example, if you have a collection of some businesses and maybe null, but you want to actually have a string, then in this case you can just say OrEmpty join to string, and then if they're there, then it will produce a large string. If it's empty or null, it will, in both cases, will produce an empty string for you. So it's just for sometimes, gets you out of nullable things that are coming from outside Kotlin. Reverse, yes, the reverse is the order of the same things that are in your collection. Zip and unzip. You can basically, zip is if you have two collections and they have to both be of the same size. When you zip the first with the second one, you get a collection of pairs. And each item, the same indexes within the second list. The item from the first list is going to be the first element in the pair. The item from the second list is going to be the second element in the pair. And then you can also unzip it. If you have like a list, like any collection of pairs, you can unzip it into a pair of two collections. If you can also zip into a custom item, into a custom complex item. So you basically take two collections and you iterate over both collections at the same time. And then for both items that you get from each of these collections, you create some other complex item. And basically the way to then unzip from a custom item is basically the associate function, which we already looked for, is you create from a complex item a map. And that was the last of it. So any questions about these? Cool. Then we'll go and make our app a bit more pretty. So in this example, we're just going to basically make the app display an entire list and not just the first item or the name of the first restaurant that is in there. That's why we had the image URL to begin with. So to do that, first we'll need to add a recycler view to our layout. So we have this text view here. And basically on top of it, we want to create a recycler view. These are going to be our search results. And we want to give it a layout manager, which is, I'm just going to use a linear layout manager. Cool, so this is basically a list now. And in here, in the fragment, this will throw the error. But in case we have a list, we want to make sure the visibility is correct. So when we start, the list is, oh yeah, let's make it actually invisible at the beginning. So we have no search results when we start the app, so this will be visibility gone. So we have none. So we have to see basically at this point, we have to see if we have visible items or not. So we'll make has results is response. Yeah. Oh, they're called businesses. Yeah, businesses is empty. Is not empty. Cool. So this will make sure that we have results. And in case we have results, then we want to make our search results visible. And we want to make our text view invisible. In case you're wondering where did these things come, because they're not, I'm not saying visibility gone and visibility visible. These are extension functions that are coming from the core KTX extensions, and they basically, you can follow these things. Like if you don't know where does this come from, where the hell is that thing? This is basically a custom inline var, which basically converts a Boolean into the visible and or visible gone. So if something is not visible, then it will automatically put the visibility to gone for me. Same is true for the gone. Is basically the opposite. If something is gone, it's going to be true. If I set it to true or false, it will just make the right thing. So that's nice. So now I know that basically things are being displayed correctly. And I have here a query. But I still don't have any adapter. So in this case, I don't want to just display the first thing because I just hit this thing. So I just want to make sure that this has not search bar, search results equals business results adapter. That takes in my businesses, so I'll give it the response businesses. This doesn't exist, so I'll just create it. Create this class, an external class. Sounds good. So this takes a list of businesses. It's a recycler view. It doesn't know of what type. I'll tell it it's a view holder. It's not this view holder. I want to create my own. So I'll make a class view holder that extends from recycler view holder. Yeah. Cool. So we have some. It doesn't know what businesses are. Should import that. Doesn't know which view holder. My view holder. Cool. Now, sounds about right. Complains that there's some unimplemented methods. There are these three that we have to implement. Start with the get item. It's very easy. Get items are my list of businesses. So equals, I'll remember that in a val. Businesses.size. Creating a view holder. We'll just make that create an instance of my view holder. Passing in the parent. I have to adapt this down here to accept that parent. So view group, whoops, still write Java many times. This works like this. And so that's cool. So this knows how to create it. And in this function, I need this that much. I'll just tell it hold. Yeah, I was wrong. Equals holder.bind the business. Bind businesses at position. Create a member function for that. There you go. So now we've completely implemented our adapter, which works. This is still a bit unhappy. It's because it doesn't have a constructor, and the constructor wants to have a view. So we're just going to say parent.inflate some layout. We'll call it the business search result. We'll complain doesn't exist. We'll create it for it. No. We'll just go with good old linear layout. It's not wrong with that. There you go. We want a horizontal one. Is this the result? And then we'll just make a simple image view. Oops. With match parent, wrap content. No, actually no. We'll just make it 80. Good square image on the left. We want it to what is it? Scale type. Then, center crop. Sounds about right. Definitely want to give it an ID. That will be our business image. This is a business result. It's just going to be called the picture. Then we want to have the title as well, so we'll just put a text view. Will be match parent. I will be 0. And then we're just going to say fill the whole remaining of the space. It's unhappy about layout with 0 instead of match parent. Oh, yeah, okay. As you wish. We'll give that an ID. This will be the title of our business. Give it some padding. Let's say 16 dp. And we'll make it nice and large. Cool. So that's me coding XML. And then we'll get them here. So we'll say I want to have an my image view, which will be item view dot find view by ID. If you're wondering where the item view comes from, this is from our parent. Basically, we just give it here. We inflate it into the parent, and we can get it from the recycler view holder. And this is our ID dot, I think I call it picture. Yeah, picture, there you go. And make the title a text view, which is again item view, find view by ID, RID title. There you go. When we bind the business, we want to set the title, so we'll say title.text is the business.name. And then we want to do some fancy glide with context. We don't have with the image.context dot load the business image URL into our image. There you go. So, and this is complaining that this doesn't exist. Make a fancy extension function for that. It's going to be on the view group. We've already seen that. I'll just implement it one more time. It was basically return layout inflator from context. Inflate. Call this the layout. Just a bit more. Inflate the layout into this. Don't attach it. The Android view. There you go. That's everything, I think. You can see our main fragment is now compiling. We're going to new adapter every time we do that. So if I run app3, you'll see a list of results. Let's see how did that Ryoko sushi look like? Like that. Something's not right. There must be more than this. Ooh, these things are very big. I think I probably, it's a bit, I was sure that this should be, width is 0 and this should be wrap content. I was just getting the wrong thing. Let's see. Look for some sushi. Whoops. Look for some sushi. Ah, that's better. It's still very. The linear layout. Ah. That should also just wrap content. Don't want it to be full screen. Oh, that looks better. There you go. List of restaurants that serve sushi in San Francisco. If you look for something that, yeah, Yelp doesn't know how to serve that. So yeah, everything works. Now, the only thing is we'll probably have to adapt our test. So let's see about that. If here test, and if we run them, I suspect this one will fail. Because we're no longer printing our test. Yeah, this one doesn't work anymore because we're not printing this. But instead, we're just interested if the first is actually visible. So we can go here and do something fancy like this and say, with text this, check matches is displayed. Cool, so we're just checking if the first business is displayed. We don't care where exactly on the page it is, whether it's inside our high text or somewhere else, and this should now pass. This works, test pass, everything's awesome. All right, now it's up to you. So have fun. And yeah, if you have any questions, do you have any questions now before we start? All right, then have fun.